Our first example is graph y equals x over x plus 1 times x minus 2. So the first thing you look for is your vertical asymptotes. So you check your denominator and you check and see where is your denominator going to be equal to 0. So right here, if x is equal to -1, that would make my denominator equal to 0. Right here, if x is equal to 2, that would make my denominator equal to 0. So here's my graph. Here's 2. I'm going to have a vertical asymptote at x equals 2. And a vertical asymptote at x equals -1. Alright, where do I have a x-intercept or a 0 or a root, whatever you want to call it? I check my numerator and see where my numerator would be equal to 0, which is at x equals 0. So right here, I'm going to have a point. And then my horizontal asymptote my degree of the numerator is 1, the degree of the denominator is 2. If you're going to FOIL this out, you get x squared. The degree of the denominator is 2. The degree of the numerator is less than the degree of the denominator, so that's when your horizontal asymptote is y equals 0. So my x-axis is my horizontal asymptote. And the weird thing about these is your horizontal asymptote really doesn't apply in between these two vertical asymptotes. Obviously, like we have a point at the x-axis, so my graph is going to cross that horizontal asymptote, but only in between these two, vertical asymptotes is it going to cross the x-axis. So I don't really know how to start my graph. I know that it's going to go through this x-axis, and I know like the behavior of my graph when it approaches these vertical asymptotes. Since they're both odd, they're going to go in opposite directions. I'm not really sure like how to start it. So the way I figured out is I plug in a test point. So I'm going to start by plugging a test point that's to the left of my first vertical asymptote. So I'm going to plug in -2 in for x. And I don't really care what the value is. I'm just trying to figure out if when I plug -2 into my function, is it going to give me a positive number or is it going to be a negative number? Is it going to be above the x-axis or going to be below the x-axis? So when I plug -2 in, I get a negative number in the numerator. -2 plus 1 is -1, so I have this as a negative number. And then -2 minus 2 is -4, so it's also a negative number. So a negative over a positive is a negative. So this number down here will be negative. So that means it's going to go up towards this horizontal asymptote and down towards this vertical asymptote. It's negative, so it's below the x-axis. Then I look at the degree of this vertical asymptote. The degree of this vertical asymptote is odd. So that means that since I'm going down towards the asymptote on the left side, I'm going to go up towards the asymptote on the right side. I'm going to cross through this 0. We talked about this before. The degree of my 0, my x-intercept, is odd, so I'm going to cut through as opposed to bouncing. Remember, if it's even, I would just bounce off of it, but since it's odd, I'm going to cut through. I go down towards this vertical asymptote. And then I check the degree of this vertical asymptote. It is odd, so that means that since I'm going down towards the asymptote on the left, I'm going to go up towards the asymptote on the right. And then I have this horizontal asymptote at my x-axis, so it's going to continue to go down and just coast along that asymptote. So clearly my graph is kind of ugly and it's not super accurate. Like, you're just getting the gist of like where your asymptotes are and how your graph is behaving when it's approaching your asymptote. Where are the asymptotes? Where are your zeros? Where's your horizontal asymptote? That's really the important information that we're looking at when you graph these. So it's okay for you to cross your horizontal asymptote sometimes. It's usually going to happen in between two vertical asymptotes. Next one. A little bit more complicated one. Y equals x minus 2 times x plus 1 squared over x minus 3, x minus 5 squared times x plus 4. So start with your vertical asymptotes. Check your denominator. Where's your denominator equal to 0? At x equals 3. At x equals 5. And at x equals negative 4. So I have 3 horizontal asymptotes. One at 3. One at 5. And one at negative 4. All right, where do I have x-intercepts? Or zeros, or roots, whatever you can call them. X-intercepts, I have to go check my numerator. Where's my numerator equal to 0? My numerator is equal to 0 at x equals 2, so I have an x-intercept at 2, 0. And my numerator is equal to 0 at negative 1, so I have an x-intercept at negative 1, 0. So I'm going to go graph those. I have an x-intercept at 2, 0. And x-intercept at negative 1, 0. Then I want to think, where do I have a horizontal asymptote? The degree of my numerator is 1, 2, 3. It's 3. The degree of my denominator is 1, 2, 3, 4. So the degree of my numerator is 3. The degree of my denominator is 4. The degree of my numerator is less than the degree of my denominator, so my horizontal asymptote is at y equals 0, my x-axis. And remember, sometimes your horizontal asymptote doesn't really apply in between your two vertical asymptotes, obviously, because we're going to cross the x-axis at negative 1 and 2. All right, now I'm ready to start graphing, but I need to plug in a test point to know, am I starting over here at the top or at the bottom? So I'm going to pick a point just to the left of this vertical asymptote. I'm going to pick negative 5. So I'm going to plug negative 5 in for x. And remember, I don't really care what the value is. I just need to know the sign. Is it positive, and so it's going to be up here, or is it negative and it's going to be down here? So first parentheses, negative 5 minus 2 is negative 7. So that's a negative number. Negative 5 plus 1 is negative 4, but a negative number squared is always going to be a positive. Negative 5 minus 3 is also negative. A negative squared is always a positive. And then negative 5 plus 4 is negative 1. So negative over positive is negative. So this is negative. So it means I'm going to start somewhere down here. I'm approaching that horizontal asymptote up here. I'm approaching that vertical asymptote down here. Now I need to check the degree of this vertical asymptote. So I can find that right here. That vertical asymptote came from this parentheses in my denominator. And the degree of this vertical asymptote is 1. So that means it's odd. So that means since I'm going down on the left side, I'm going to go up on the right side. I'm going to go down until I hit my 0. And then I need to think about the degree of my 0, because am I going to bounce or am I going to cut through? So that 0 is negative 1, which came from right here. And so since the degree of that 0 is 2, it's even, so I'm going to bounce. Then I'm going to come down and connect to my other 0 at 2. So I need to go check the degree of that 0, which I see up here is 1. That makes it odd, so that means I'm just going to cut through it. And then go down towards that vertical asymptote. So now I need to check what is the degree of my vertical asymptote, because I'm not sure if it's going to go down here or if it's going to be up here. So I check the degree, which came from right here. It's odd, so that means since it's going down on the right, or sorry, on the left side, it's going to go up on the right side. I don't have any zeros in between 3 and 5. There's nothing up here that told me I had a 0 in between 3 and 5. So I can't cross through that x-axis because I don't have a 0. So my graph is just going to go back up because I cannot cross the x-axis. Because if I did, then there would be another 0 up here, but there's not. I'm going to go back up and approach that vertical asymptote. So now I need to check the degree of this vertical asymptote at 5, which came from here. The degree of this vertical asymptote is 2, which is even, which means that instead of them going in opposite directions, they're going in the same direction. So it's also pointing up on the right, and then it goes down to follow along that horizontal asymptote. Go ahead and pause your video, try this U-try problem on your own. Graph y equals x plus 3 squared times x. And in this, let's do x minus 2 squared times x plus 5. Pause your video, try this on your own, copy down your paper. Alright, where are my vertical asymptotes? They're at 2 and -5. Okay, where are my x-intercepts? X-intercepts are at 0 and -3. Where is my horizontal asymptote? My horizontal asymptote, well, the degree of my numerator is 3. The degree of my denominator is 3. This is interesting. So this is when the degree of your numerator and the degree of your denominator are the same. So when the degree of your numerator and the degree of the denominator are the same, your horizontal asymptote is found by taking the leading coefficient of your numerator and putting it over the leading coefficient of your denominator. So the leading coefficient of your numerator is 1. Leading coefficient of your denominator is 1. So your horizontal asymptote is at y equals 1. Which is like up here. Alright, so we need to go plug a test point in to see where are we going to start our graph. So here's the asymptote at -5, so let's plug in -6. So that's a really ugly 6. -6. If I plug in a negative here, it'll be negative. But anything squared is always positive. Anything squared is always positive. And -6 plus 5 is -1, so it's a negative. This is positive. That means I'm going to be coasting along here and going up. Positive, so it's going to be above that horizontal asymptote. And then we need to check the degree of our first vertical asymptote. It's odd, so since it's pointing up towards that vertical asymptote on the left, and then it's pointing down on the right. So we're going to hit that 0. And the degree of that 0 is even, so we're going to bounce. Then we have to go cut through this 0 as well. And the degree of that 0 is odd, so we're going to cut through. And remember, it's okay if you cross your horizontal asymptote when you're in between your two vertical asymptotes. Whoops. And then last but not least, check the degree of this final vertical asymptote, which is right here. And the degree is even, so that means that they're going to point in the same direction. So it's going to go like this. Voila.